So hi, this is the second part of this lecture. This is about classes in C++. The first part was slightly shorter. Actually, I think I should have put at least static members in the first part. So this is slightly longer in length, but we have to cover all this in now. So this is what we covered in the first part. We now know what are namespaces. Namespaces are basically collections of declarations and definitions, and we know that the fields of a particular class could either be public or private, and this decides their visibility, whether they are visible outside the class or not. And we also know about something about a special type of method called constructors. So these constructors are essentially in some ways initializers, which can initialize the different fields of a particular object when you create them. So all these things you already know. There is one more type of constructor that we will cover in this particular lecture. It's called copy constructor, and we did not discuss the static members of a class. So that too we will do now. So you realize that in order to access a particular field, we use that notation, right? Class name dot the field, given that it's accessible at that particular point. Now, what it really means is that there is a copy of this field for each and every object that is created of this particular class. Now, in certain cases, you might actually want to have a variable or some information which is not really specific for one particular object, but it could be something that is associated with the class itself, right? So, one very common example, which we will see in the code, is that let us say you want to store how many objects of this class has been created till now, right? So this is an information, this is a field in some ways, which is not really associated with uh, any particular object, right? This is an information, a piece of information that is associated with the class. So static members are essentially fields or methods. They can be both. They can either be fields or methods, but they are essentially associated with the class and not a particular object, right? Um, if it is a field, then there is only one copy of this particular field that is maintained for the whole class. So it doesn't matter how you access it, and what exactly are you going to do with it. Whatever changes you make to this particular copy, it will be visible across all the objects, for example. So the static methods, they are in some ways um, their usage is rather limited. Why? Because the only fields that they can work upon are the static fields. They cannot work upon the non-static fields. I mean, they can, but then we'll have to use that same notation, right? Object dot field. So the reason for this is that static methods again are associated with the class, so they can only operate on data that is associated with the class. If they want to operate over any data that is associated with a particular field, then you also need the access to that object. That is the overall idea. And all these access rules for public or private, they are also applicable to these static members. And if you want to access them, this is how you do that. You basically use the class name, then the scope resolution operator, and then the name of the static member. So you can see that the access itself shows you that it is not associated with an object, but it is associated with a particular class. We'll have a look at an example now. So this is the same toy example. I have extended it a little bit, but here I have two static members. Okay, so there is a member called counter, and there is a method called reset counter, right? So one more thing that you should know is that static members are initialized by default with a zero. So zero, as in if it is an integer, it is zero. Otherwise, if it's basically zero equivalents of whatever are there in the different data types. And this is how a particular static method is defined. It is actually defined in exactly the same fashion as some other methods. The only thing that is different here is that the only variables it can work upon are, let us say, either the local variables, constants, or the static fields of the class. So Uh, the, the major purpose of using static fields is often to keep some information associated with the class, right? So here we are using this variable counter um, keep the number of to keep a count of the number of objects that are being created for this particular class. The reason for this is we want to assign a unique ID to each toy that is being created, and here we are saying a toy means the object of toy class. So for each toy that gets created, it gets a unique ID, and one way to do that is basically you maintain a counter. So each time an instance of toy is created, you increment the counter, and so each toy gets a unique ID. Now there is another type of constructor that we did not see in the previous part of this particular lecture. This constructor is known as the copy constructor. So when this exactly is a copy constructor called? A copy constructor is called whenever, as the name suggests, you need to make a copy of a particular object, right? So this copying thing could either be implicit or explicit. When I say implicitly, let us say you are going to pass on a particular object to a particular method via value and not by reference. Okay, in such a case, the copy constructor of that class is invoked. Now, similar to the default constructor, in case you are not going to provide a copy constructor explicitly, the compiler adds one for you, right? But to be honest, in most cases, you really don't need to define a copy constructor. The compiler actually does a good job. So, but yeah, in certain cases, for example, when you are having some dynamic memory that has to be allocated, then you may have to create these copy constructors. So this is an example of how what a copy constructor looks like. So you can see that basically the argument of this copy constructor is essentially a type of toy itself, right? And this ampersand that you are seeing here, this is something that is specific to C++. If you remember the discussions we had in the previous semester when we were having a look at C, I said that in C you basically either pass things by value or you have to pass a reference via by an indirect method, and that indirect method was passing the address of that particular variable and then catching it in another pointer. In C++, you actually have an explicit concept of a reference. So essentially what is really happening here is you are passing a variable to this constructor via reference. This ampersand is essentially saying whatever is being passed from the caller to the called function. Essentially, you are going to have a the changes that you make to copy, for example, will be visible in the calling function. So anyhow, so this is a copy constructor. Just for now, assume that this is more like C's version where we used to pass the pointer to the variable. So here what we are doing is the fields of this particular class, we are just assigning the respective fields from the copy object, and then just some message. This is not really necessary. As I said, in most cases, whenever we are not having any kind of dynamic memory allocation, we really don't need to give a copy constructor. But this is just for showing you what it is. So anyhow, we now can move to the part that ideally I should have started from here. I should have put the rest of the stuff in the first part itself. But this part is more about inheritance. So we now know the concept of inheritance. What exactly is inheritance? You basically start with a more generic version of some functionality, and then you try to specialize it to different levels. So that whole concept of inheritance, we are going to have a look at it how to do that in C++. By the way, I have put single here in parentheses because C++ also supports multiple inheritance, but we'll talk about it in the next week. So for now, whenever I say inheritance, it means that a particular class is going to inherit from just one class. Okay, and that is why it is called as single inheritance. So now let us extend our toy example. So let's just say from toy you now want to create another class, and let us say this class is battery operated toys. Okay, so there are certain toys which require battery, some kind of batteries actually, and you want to keep some information related to how what kind of a battery is required for this toy, what are the number of batteries you need to put in, like three AA batteries or two AA batteries, something like this. So again, going back to what we did in the previous part where we saw that example of T20 and T10 and ODI and limited overs cricket, you can either create the battery operated toys class from scratch, or you can simply extend the toy class and then add some more behavior to it, add some more fields, some more behavior to it. And this behavior is basically with inheritance that we have seen in the previous week. So this is how single inheritance works in C++. You essentially start like this. You say this is the name of the new class, the class that is going to inherit from the existing class, and then you put an access specifier here, and then you put the name of the base class. So this is the base class, and this is the derived class. Now, what exactly is this access specifier? I'll just tell you. But there is one more access specifier that we are now going to talk about. Till now, we only know about public and private, but now I'm adding one more to this list, and this is known as protected. I'll just talk about it in a second. But the reason to put this access specifier is whenever you are going to import, right, I'm calling it import, but the actual word is inherit. So whenever you are going to import something from the base class, where exactly are you going to keep it? That is the idea, right? So whatever fields, whatever methods are going to come from the toy class, they have to be put in some access section, right, in this battery operated toy class. So this is what this particular access specifier tells you, that whatever are you going to inherit, where should it go. Now when I say public, it doesn't really mean that everything that is being inherited is going to go into the public part. I'll come back to this part, but let me first talk to you about what exactly is this protected specifier. So till now we know that there are only two types of visibility for fields and methods, right? Public and private. Public means it is uh, visible to everyone, and private means it is visible to none, right? Okay, it is not at all possible to access it outside the class. Now, another issue that you have probably already known is that private members of a class can never be inherited, right? Because they are the private properties of the class. It's the same discussion that we had about modification versus extension. So, what part of the class do you not want to be modified? So you can make that thing as private, and once that thing is private, it cannot be inherited. Um, Now the problem is if you make it private, you know the derived classes will also not get this field or this method. So there is a midway out of it, and that is known as protected. So this protected access specifier is used whenever we need to do some kind of inheritance. A protected specifier is it behaves exactly the same like private as long as there is no case of inheritance. But whenever there is a case of inheritance, along with the public members, the protected members of the class are also inherited. Okay, so they behave like private members for rest of the world, but if it is a derived class, they behave pretty much like a public member. They're not exactly public, but yeah, similar to public. They get inherited. So protected is something that is only applicable in case of inheritance. Otherwise, it is just the same as private. So when I talk about that access specifier, I said that whatever gets imported, if you put public, it should go in the public section. It's not really true. This is what really happens. That is, say, in the base class you have public members, protected members, and private members. Now, private members, as I said, cannot be inherited, but public and protected members can be. So if I put public here, it basically means send the public members to the public part of the direct class and send the protected members to the protected part of the class. So essentially what I'm trying to say is the access rights of the protected members are not really degraded. Okay, they still remain protected, and the public members remain public. If you make that access specifier as protected, then these public members of the base class they are no longer accessible to the outside world using the objects of a derived class. So basically, I have in some ways upgraded the public members to become protected. And similarly, if I make this access specifier as private, whatever gets inherited, whether it is public or protected, it goes into the private section of this class. So now, not only is this away from the reach of rest of the world, it is also away from the rest of the from any derived classes which are going to derive from the derived class. So let us say there is one more class here, which let me call it derived class 2, which inherits stuff from derived class. If I make this access specifier private, these members are not going to be available for inheritance for this second derived class. So this is it might seem a little complicated in the beginning, but one way to realize it is that in most cases we use public. Okay, in most cases, unless you have a very good reason, you should not use private or protected, because then you might actually hamper uh, the inheritance hierarchy. So in most cases we use the public access specifier here. In some cases it could be protected. In very few cases should you go for private. So you should convince yourself that this is exactly what you want. Now, whenever we talked about constructors, we realized that constructors are something that initializes the object of the newly created objects. Now, you saw that, let us say, if I create an object of battery operated toy, there are certain fields which are being inherited from toy, and it's not just that these certain fields are inherited. Essentially, when you create an object of a derived class, um, the space is also reserved for the fields of the base class, right? So even those fields which are not really inherited, right, they may not be accessible to you, but space in the memory is allocated for even these fields as well. So, it is quite clear that in the derived class constructor, you will only assign values to the newer fields that you have added to the derived class, or maybe the fields that you have inherited. But there might certainly be certain fields which you do not have access to, because these are private fields of the base class, and even though space has been allocated in the memory for them, you do not have access to them in the derived class. So whenever I call the constructor of the derived class, um, there is no way for me to initialize these fields, the private fields, for example. So there is a chain reaction that happens whenever you call a constructor. So what really happens is the the the, the objects are created in the reverse order. So basically, the constructors are called from base to derived, right? So essentially, if I have a derived class and a base class, and if I access the constructor of the derived class, the first thing that happens is some constructor, I repeat, some constructor of the base class has to be invoked, so that all the necessary fields of the base class are initialized, and only then the derived class constructor is called. So this might be a slightly complicated concept for you to understand, but the idea is we are going to build our objects in a bottom-up fashion. So at the bottom-most layer, you have the base class, the class which is not inheriting from anyone, then the next derived class, and then the next derived class. So if there is an inheritance hierarchy, the last class whose object you are trying to create, the constructor for that class, it gets called at the end. Okay, because you have to build up the stuff in a bottom-up fashion. So, so the idea is some constructor from the base class must be called. Now, in certain cases, when there is a default constructor, you don't need to invoke it. By default, the compiler will invoke the default constructor of the base class for you. But we saw that in certain cases, if you have defined even one constructor that is not default, then the compiler will not add default constructor for you. So in such cases, you have to explicitly call some base class constructor, so that this whole construction process can go through. So this in C++, this is how you actually do that. Essentially, this battery operated toy constructor, it has to first make a call to the toy2 constructor. Okay, so I'm using the parameterized version of so this toy2 class had two constructors. Okay, this is the one that we have already seen, and this is the copy constructor. And so the battery operated toy class, it also has two constructors. One is the parameterized constructor where you are sending the values uh, to be assigned to the different fields of this particular class, and the second one is the copy constructor for this one. And you can see that this is the way to actually invoke the the constructor of the base class first. So this particular statement, okay, this is, please keep this in mind, that while this part, okay, up to here, up before this colon, this is basically a kind of a function header. You're defining a function header, that this is the name of the function and these are the parameters of this function. Whereas after colon, whatever you have written here, this is a function call. Okay, so this is actually calling the base class constructor. So the idea is that first this call gets through and only then this code is executed. So this is the idea that you have to understand. Whenever you have a class hierarchy, the constructors of the class are called in the order of base to derived. So the the class that is at top gets the constructor for that class is called first, and then it basically goes up to the derived levels. Now, one in certain cases, you might actually wish to provide access to the private members of the class externally. Okay, you already know that private members cannot be accessed from the outside world. Well, in most cases they can't, but there is one way out. Okay, you can essentially create a friend of a class, right? So what does it mean by being friend? So basically, you say that there is a function out there who I trust. Okay, as the creator of this class, I trust this function. Whomsoever is going to write this function, I trust that person. I trust this function, that this function is not going to do anything funny. So in that case, I call that function. I can declare that function as a friend of this particular class. So a friend function can access the private members of a class. Okay, private as well as protected. I should have written protected here as well. So basically, it can access all the members of a particular class. And this friend function can also be, by the way, a method from another class. Okay, so let us say there are two classes class A and class B. You would probably want to allow one method from class B, let us say F, to be able to access the private and protected fields of this class A. So in that case, we can also make the member function of one class as the friend function of another class. Now, if you wish to make, if you realize that there are far too many methods in class B for which I have to create a friendship relationship, there is also an option to make a whole class as the friend of another class. Okay, so there can also be friend classes, not just friend functions, but friend classes as well. And this is how you give the information about friend function. So whenever you are declaring your class, you basically just say friend, and this is the the prototype of your the declare a kind of declaration of your function here, and just that you are putting the keyword friend before that. And while you are actually declaring the friend function, you might need the name of the class, because yeah, by the way, the friend function cannot access you cannot access a friend function like a member function, right? So it's not like object dot friend function. No, that is not possible. It is still an external function. So if you want to apply any operations in this friend function, you'll have to probably send an object of that type as parameter. This is the most common case where in friend functions we send an object of type a type of that particular class, and then we can simply access the private fields using the object dot field notation. So when you declare this function, because this function has to be declared and defined as well, we often give something known as forward declaration. So basically, I just say that later on you are going to find a class called battery operated toy, and this function is going to take an input of this particular type. And this is how friend functions could be defined. You can see that I'm passing an object of toy here, and then this in use is a field which is essentially inaccessible to the outside world, but here I have no issues because it's a friend function. This is perfectly legal. If I had tried to do this, let us say directly in main, it would have given me an error. But since this repair toy is a friend function for the class battery operated toy, this is perfectly legal. So there's just one last point that is left in this lecture. I know it's already too long, um, but yeah, this is the last point of it. So in some cases, we did talk about what is overriding, right? I mean, in overriding, we basically extend the behavior of the base class within the derived class. So the idea is that, let us say there is some method which is defined in the base class. You may want to have a more precise or slightly different definition for this function. This is what we talked about in the previous lectures. So in C++, one way to do that is by um, declaring the function as virtual. Okay. So what exactly does virtual mean? Virtual means that you are basically telling the C++ compiler that whenever this particular class is extended by a derived class, it is possible. Let me put this, you know, let me put some emphasis on this. It is possible that the derived class might provide a different definition for this function, for this method. It is not necessary. Let me make it absolutely clear that it is not necessary for the class to the derived class to give another definition, but it may give another definition. And in this case, you can the compiler will make sure that the correct definition is used when you start using the code at the runtime. So this is an example of a virtual function. We had two of these functions, start playing and stop playing, right? In the simpler toy example, and these methods were just printing things like you are now playing with this toy, with the ID and stuff. So let us say for battery operated toy, I want these functions to be slightly more complicated, right? Complicated as in I first want to see if the battery has already been put in the toy, because without that the toys cannot be played with. So here I want to add some more behavior to these start playing and stop playing methods. So one way to do that is something like this, right? And by the way, I still have access to this base class version by simply using the scope resolution operator. So what I'm really trying to do here is I'm putting some additional messages here. I am putting some if conditions here, and based on that, I'm also using the functionality from the base class, and I'm adding some more functionality in the direct class. So these messages are going to be added only for the battery operated toys, and then the older message that start playing and stop playing was printing, that too can still be printed using the scope resolution operator. And this is the example how will it work. In the when you create an object of type battery operated toy in the main, and you do this start playing, you see that I have not yet put any batteries in this toy, and then if I try to do start playing, this is what happens. Okay, it is this toy is not yet ready for playing. This is coming from the start playing method, and then I tried to put batteries. Finally the batteries were installed. Then after that, when I called this start playing again the second time, now it will say switching on the toy, and then this you are now playing with kids piano with ID1. This is actually coming from the base class version, right? And this switching on the toy, this is coming from the this is coming from the derived class version here. So yeah, it's finally over. It's a very long lecture, I know. When we'll discuss it in the class, maybe we can spend more time over it. If you have any issues, there is some homework. Have a look at it, and enjoy. I know that you guys have just finished up your midterms, so you are getting a few days off. So please enjoy. Bye.